Hello everyone, and welcome to Down the Runway, Energy Modeling Through the Eyes of LEED v4, brought to you by Green CE Academy. My name is Sarah Ward, and I have the pleasure of being the moderator for today's course. I will be introducing you to today's instructor, giving you a little bit of an idea of what he'll cover today, and then I'll pass it off to him so we can get started. Before we discuss today's course description, I'd like to introduce today's instructor. Kyle Franson currently works with Balfour Beatty Construction. He is a LEED AP with Building Design and Construction Specialty and functions as a Sustainability Project Engineer for Balfour. Throughout today's course, we will be discussing energy modeling as it relates to green building, but more specifically to LEED projects with LEED version 4.0. This course will provide an overview for energy modeling overall, an introduction to the relevant LEED v4 credits, and also delve into how energy modeling can be applied to a real project with a LEED v4.
In the next few slides, we're going to discuss energy consumption, which is one of the reasons why energy modeling was created to begin with, and hopefully the next few slides will shine some light on why it's so important to conserve energy. The United States of America is the second largest consumer of energy, right behind China. And within the United States, the energy consumption is mainly within transportation, commercial, residential, and industrial. And the major energy sources consumed in the United States are petroleum, or oil, natural gas, coal, nuclear, and renewable energy. The major users are residential and commercial buildings, which we'll talk more about later, as mentioned before, but industry, transportation, and electric power generators. The pattern of fuel use varies widely by sector. For example, oil provides 93% of the energy used for transportation, but only about 1% of the energy used to generate electric power. Understanding the relationships between different energy sources and their uses provides insights into many important energy issues. Certainly one of the key driving factors in energy modeling has been LEED. The past decade has seen remarkable growth in the building energy modeling industry, primarily driven by more stringent building standards and a growth in voluntary certification programs. In 1998, the United States Green Building Council, or USGBC, released the pilot version of Leadership in Energy and Environmental Design, LEED, known as LEED 1.0. LEED 2.0, released in March of 2000 to the marketplace, quickly followed. However, it wasn't until later in the decade that LEED would drive demand for energy modeling. In 2007, LEED introduced a 2-point minimum requirement for the Energy and Atmosphere Credit 1, EAC1. This required a building to meet certain energy reduction criteria in order to receive LEED certification, and about 90% of EAC1 submittals relied on energy models to demonstrate this. In 2009, the United States Green Building Council introduced LEED version 3, its most recent version, prior to the launch of LEED version 4 in November. And this version 3 weights each LEED credit according to its overall importance. EAC1, which relies on energy modeling to quantify the predicted energy savings over a baseline, is the most heavily weighted credit. This is translated into the use of building energy modeling for nearly every LEED certified project. So we've learned about energy modeling, and LEED v4. And this is the perfect place for everything to come together in a real-world application. The case study we're going to be talking about is the Energy State Building Retrofit. It's a perfect example of everything we've been discussing during this section. It shows significant savings can be achieved through energy modeling and an integrative design approach.
Teams from the Clinton Climate Initiative, energy consultants Rocky Mountain Institute, building efficiency experts Johnson Controls, and real estate services provider Jones Lang LaSalle gathered in the summer of 2008 for an innovation workshop to overcome the diverse challenges of retrofitting commercial buildings.
Everyone talks about energy modeling. Well, we do energy modeling. Everyone talks about building a building profile for energy consumption. Well, we've built it. Everyone talks about determining what the impacts will be from different investments and changes you might make. Well, we're actually doing that here.
So via the windows, the envelope, controlling outside air, and through all of those measures, we're able to put in less supply to the building and make it a more efficient as well as comfortable place.